Hello students, welcome once again to our TEJAS series. So that's the second question of coordinate geometry. First, of course, I believe you all would have understood. Okay, we had that solution, video solution, and so now let's move to the second question. So again, see, it's a good question if you can apply the concepts, the theorems which we already know. Okay, so let's see what theorems, what concepts are we going to apply here. The statement is that there are 6 points on this circle which follow these relations. Their abscissa, their ordinates follow this relation. Now consider a line. There's a line joining the orthocenter of triangle formed by any 3 points out of those 6 points, and then it also passes through, of course, a line. To fix a line we need 2 points. Okay, orthocenter and centroid of the triangle formed by another remaining 3 points. Okay, then we have to prove that if always that line that passes through orthocenter of one triangle and centroid of another triangle always pass through a fixed point, and then we have to find this alpha plus beta. Okay, so let's start. See, so first of all, since we are given a circle, so let's try to draw a circle on which we'll claim there are 6 points: A1, A2, A3, A4. You can put them in any order you want. Okay, doesn't make any difference. Where, see, instead of writing for all of them, I will write here AI is nothing but xi comma yi. Okay, for reference, because that's what we are going to use. So now if I consider one triangle as this one, A1, A3 and A5. Okay, so let us find its orthocenter. So shall I ask you one thing, that what are the coordinates of its circumcenter? So of course, since the circle is the circumcircle for this triangle, any triangle joined by like 3 points on this circle, so it's the same circle. So that means its circumcenter is 0, 0. Okay. And then what is the centroid? So I am writing it as G1. Centroid of this triangle is, we know about the centroid, sum of all the abscissa by 3 and sum of all the ordinates by 3. So it will be x1 plus x3 plus x5 by 3, comma y1 plus y3 plus y5 by 3. Okay. Now see, that's what I said. We'll be using here so many things, like first thing is orthocenter and centroid and circumcenter of the triangle. They are always collinear, and centroid divides the line joining O and C in the ratio 2:1. So do we have coordinates of circumcenter? Answer is yes, we have. Do we have coordinates of centroid? Answers again yes, we have. So x1 plus x3 plus x5 by 5, and then y1 plus y3 plus y5 by 3. I'm sorry, I don't know why did I write 5 here. Okay, so that's 3 here, fine. So now what? Now we have to find orthocenter. Just use section formula. So I will say, okay, let us say that the coordinates of orthocenter are P and Q. So what? 2 into 0 plus 1 into P upon 3. So P by 3. So therefore P by 3 is nothing but x1 plus x3 plus x5 by 3. And similarly Q by 3 is again y1 plus y3 plus y5 by 3. So what do we get? So from here we get that orthocenter of first triangle OH, okay, is nothing but x1 plus x3 plus x5 comma y1 plus y3 plus y5. Achha, for the second one there is not a problem, because centroid I am writing it as G2. G2 sum of centroid is always sum of all the abscissae by 3 and sum of all the ordinates by 3. So whatever is left, so x2 plus x4 plus x6 by 3, and then it's y2 plus y4 plus y6 by 3. Okay, let's have the equation of line passing through these 2 points. So what are we going to use? I will prefer to use 2-point equation, form of equation of line. So considering this to be maybe maybe this to be x2 by 2 and this as x1 by 1. Okay, so y minus y1, y1 plus y3 plus y5 is equal to y2 minus y1. Okay, so this minus this, fine. So acha, now what? Sum of all the ordinates, that's what we are given. Okay, we are given that y1 plus y3 plus y5 plus y2 plus y4 plus y6 is how much? I think it's given to be 4. Let's check it out. So it's given to be 4 and sum of all the abscissa is given to be 8. Okay, so that's 4. So we can definitely replace y1 plus y3 plus y5 by 4 minus y2 plus y4 plus y6. So it will be 4 minus y2 plus y4 plus y6 minus y2 plus y4 plus y6 by 3. So okay, fine, doesn't matter. Okay, so I'm just doing y1 minus y2, है so that won't make any difference because then I will be using x1 minus x2, so it will be 6 minus x2 plus same thing. Okay, similarly we can write for abscissa also, x2 plus x4 plus x6 by 3. Okay, now see, instead of continuing with these terms, what we can say here is, okay, let us replace y2 plus y4 plus y6 by some number s. And then because you see, these are fixed points, okay. So, and then x2 plus x4 plus x6 by t. Now, let's simplify in terms of s and t. So, we have y minus s is equal to 12 minus 3 minus 4. So it's like 12 minus 4 s, y coordinates are for s. Okay, 4 s, just a minute, 4s upon this is 18 6, that was 8 I suppose, just a minute, right, that's 8. So I am just writing it here. So that's it. Okay, so 24 minus 4t into x minus t. Okay, let's cross multiply. So but before that, let's cancel this. So 3 4 6 and this is gone. Okay, so 6 minus t into y minus s is equal to 3 minus s into x minus t. Now let's simplify it. So what do we get? 6y minus ty minus 6s plus st is equal to 3x minus sx plus st minus 3t. So these two terms get cancelled. Now let us collect the terms of s and t. Okay, so what do we get? Just a minute. So t is here, so it's minus t. Do we have t? Yeah, we have t. So t times y minus 3 plus s times 6 minus x plus 3x minus 6y equal to 0. That's what we got. Okay, now see, can we have a s and t here or maybe x and y here, okay, which satisfied all this thing. Okay, so see, if I replace maybe s by 2, let's just a minute, bacho. Okay, so or rather I think it will be better if I come, just let me try this way also. Let us collect the terms for x, which is 3 minus s. For y it will be t minus 6, and then we have minus 3t plus 6s equal to 0. Okay, yeah. So if I put s as 3 and t as 6, so it is being satisfied. So if I replace here, so let s be 3 and t be 6 here. Okay, so does it get satisfied? So this gets 0, this gets 0, and 3t 16, and that gets satisfied. But we don't need actually s and t. We don't need actually s and t, we need x and y, because it has to pass through a fixed point. Okay, so let's try it. So we have minus 3 6s. So let us say x be 6 and y be 3. Then okay, so now put it other way. Let x be It is just a minute, 3 6 and YB 3. Now let's check whether it satisfies it or not. Okay, let's try. So 18 minus 6s and then this is 3y, which is 3t minus 3t gone, 18 minus 18 gone. Okay, and then this is right. For S3, T6 and then 6, 3 and this is 8, we will get the answer. Okay, minus 18 and this is plus 18, minus 18 plus 18 is the answer. So the fixed point is 3 comma 6. So the fixed point is 3 comma 6 here. So alpha and beta. So the alpha plus beta has to be 9 in that case. That you people can check if there is any calculation error or not. I don't think there is a calculation mistake, but okay, that you can check, but that's the procedure. Okay, this is how we can convert it to this form. If you can conclude from here, it's okay. If you can conclude from here, it's okay. Okay, but from here we can say that if I replace S and T by 3 and 6, then the fixed point is for sure 6 and 3. So the fixed point is 6 comma 3 here. Okay, or anything else? No, that's fine. Okay, so according to me, if there is nothing wrong in the calculation, so alpha beta is 6 and 3, and so the sum should be 9. Okay, so the sum should be 9 bachos. So that's the question of coordinate geometry here.